Hello students, welcome to part 2 of your video lesson on lesson 3.7 about similar triangles. In our last video we got introduced to the idea of polygons or shapes being similar, what that might mean, what that requires of the shapes. And the two things that we talked about are that when we have similar polygons, specifically in this chapter similar triangles, all the corresponding angles need to be congruent, which we can see here, A, E, B, D, C, F. And also all corresponding sides need to make equal ratios. Okay, and that's what we're going to talk about more in this video, is what do we mean by the corresponding sides making equal ratios? Now, in the last video, we matched up our corresponding sides. In this video, what we're going to do is we're going to make ratios or fractions out of those corresponding sides, okay? So as an example, if I take the length of segment AB, for example, and I make that into a fraction with the length of segment ED, right? Because we know those are corresponding segments, right? AB, ED, those are corresponding pieces. That fraction, or that ratio of AB's length, however long this is, over this length, needs to be equal to let's say BC, which is another side of this smaller triangle, over, let's see, what's the corresponding side with BC? Well, in this case, the corresponding side with BC is DF, okay? And then that also needs to be equal to the third pair of corresponding sides as a fraction or ratio. Okay, so the third side would be AC, on the top of the fraction, that's the smaller triangle over here, over, in this case, EF. Okay, so these three fractions, I group them all together. These three fractions here, I think I can do this. Yeah, okay. Those three fractions all have to be equal to each other, okay? So what this allows us to do is it allows us to set up what we call proportions, two fractions equal to each other with one missing piece, and solve for that missing piece, okay? Figure out the value of that missing piece. So for example, let's say that I know that segment AB over here is 3 inches long, okay? 3 inches. AB is 3 inches. And I know that ED right here is 8 inches long. Okay, if I know that BC across the bottom is 2 inches, the question is, what is this length corresponding to that 2 inches? Okay, and because I have these equal ratios of my corresponding sides, I can set up a little equation and solve that equation for this unknown value down here, which I will call X. Okay, this length is going to be X, DF. That's what I'm looking for, is DF. So what I do is I take the corresponding side pairs that I know and I make them into a fraction, in this case 3 over 8. It would work the same way if you did 8 over 3 as long as you do this next part also upside down. So I do 3 over 8, small triangle, big triangle, and then I take the 2 inches from the bottom of that small triangle and I put that over some unknown value which I'm trying to figure out, this X down here, because that's the corresponding side with my 2 inches, okay? And then this proportion can be solved by what we call cross multiplication. It's also known as the fish method. If you took Algebra 1 with me, we probably talked about that. And it looks something like this. Okay, we start where the X is, but we go to the other number. We multiply across, then we divide going that way, and that equals our X. Okay, so we multiply, we divide, that gives us X. So if we do 8 times 2, we get 16. If we do 16 divided by 3, that gets us like 5.3 or so. 5.3 repeating forever inches. Okay, and that is my value of X. X right here would be 5.33333333333 forever. Okay? Inches. That's the value of X. And it comes from this proportion right here, okay? So If you don't remember the fish method and you're looking for cross multiplication in this case, when we do 2 times 8, we get 16. And then when we do 3 times x, we get 3x. So we set up this new equation where we've cross multiplied this way and cross multiplied this way, and those two answers get set equal to each other. To get this x by itself, then we just divide away the 3, and we get back to this 16 divided by 3, 5.3 repeating answer. Okay? So this is what your homework is about tonight, or I should say tomorrow. The second part of your homework, numbers 11 through 16. They want you to start by, again, finding those corresponding side lengths, okay? This side length or this segment corresponding to this one. Then they also give you some fractions like this, where they have a few triangles for you to look at, and they want you to say, okay, if I put this side over this side, then I need to put what side over what side for the equal proportion, okay? So just as a quick example of that, so you know what I'm talking about. If we have some similar triangles, okay, these two triangles are similar, and I'll call this one X, Y, Z, and I'll call this one P, Q, R. Okay, if I were to set up as a fraction, if I were to set up, let's say, ZY over RQ, that's equal to what? Well, ZY over RQ, that's this side and this side. So I can pick either of the other two side pairs and I can make myself a proportion, okay? So what I'm gonna do is I'm gonna say XY over PQ. Okay, but it would be perfectly okay if instead of XY over PQ, you had said, you know, ZX over RP. Okay, so we're just, again, matching up these side lengths with their 2-letter names and saying, okay, if you put this one over this one, then I'll put this one over this one, right? Big triangle, small triangle, big triangle. That's what they're asking you to do in number 12. Now, the only other thing I need to point out to you is in number 16, I believe there is a typo in your books. So I have the picture right here for number 16, in your practice problems. And they list out for you a bunch of information in this picture. They tell you that this side over here is 12, HJ is 12. They tell you that WY is 6. Okay, and then they tell you that YX down here, this bottom side is 18. Okay, so that side's 18. Then along JI, they put an H. Okay, so the first thing that they want you to solve for is H. So part of your answer for that is going to say H equals whatever, and it's going to come from these proportions, okay? 6 over 12, 18 over H, cross multiply, and so on. But then they do this weird thing where they have a 20 up here on HI. Okay, they have a 20 up there on HI. And then they also have a Y up there on HI. Okay, so they have a Y and a 20 both on HI for some reason. That Y, you guys, is supposed to be here on WX. Okay, WX is the other unknown piece, and they call it Y, which I think is kind of stupid because they already have a Y as a corner of a triangle, but now they have a Y as a variable they want you to solve for. So it is what it is. The other part of your answer is just going to say Y equals something, okay, and it's going to come from WX relating to the 20 here, and then maybe the 6 and the 12, okay? So if you have questions or concerns about these proportions, setting them up or solving them, please reach out to me. Phone, email, or Zoom office hours are all great. Otherwise, that's all I have for you, and we will talk to you soon.